So now let's talk about seeds, segments. What type of segments we have, and basically what is their meaning also. So we will be using these terms a lot. Seed, segment, label. If I am talking SRMPLS, I will use interchangeably. Please deal with it. Segments will be distributed via IGP or BGP. This is, of course, different than traditional LDP or RSVP because, as you can see, IGP you need to have for them. So IGP plus LDP we say, or IGP plus RSVP we say, when it comes to segment routing, the segment values, whatever those segments are, we will talk now, node, adjacency, anycast, lots of segment types, they will be advertised within IGP update itself, not as a separate another protocol we have here, just IGP or BGP. Okay, that's the idea of segment routing. But this one will be one of the winning points, actually, when it comes to network simplicity, for example, of segment routing compared to IGP LDP solution, IGP RSVP solution. Just because of that, segment routing would be preferred all the time. No, of course not. This is for the simplicity requirement. Simplicity is very, very important. Functional, non-functional requirements, then maybe. Segments distributed by IGP are called IGP segments, and those distributed by BGP are called BGP segments. BGP plus label, when we say, why we are saying BGP plus label? Because MPLS label, in that case, advertise for the BGP prefixes by using BGP. Because anyway, BGP cannot assign label for IGP prefix. If you are learning prefix via IGP, MPLS label has to be assigned via IGP, one of those IGP-based protocol like LDP, RSVP, etc., or segment routing. But if prefix is learned via BGP, BGP will assign a label for that. Okay, Orhan, what is segment routing? Again, BGP is carrying the label. Good. There will be more segment type in the future. We have what we have as of 2021. I will be explaining now. I will be showing you. Even this one is not entire list. I just got the common ones. We will be discussing now. So overall, we have IGP segments and BGP segments. So, and even when we talk about, when we categorize them, we have IGP segments also, IGP prefix seeds, and IGP adjacency seeds, as you can see. When we come to BGP, I will show you this kind of chart again. But at the moment, so segments, IGP segment, BGP segment. Now, as you can see from this picture, IGP segments, we will be discussing IGP prefix segments, IGP adjacency segments. And IGP prefix segments, basically IGP anycast or IGP node segments. Segment seed, we are using interchangeably. When it comes to IGP adjacency seed, actually we should say also here maybe layer 3 adjacency seed, because when you hear from me or from any resource, first you should remember if adjacency seed you are hearing, it is layer 3 adjacency seed. But we will see how adjacency seed can be assigned for the layer 2 links as well. Okay? And for group bundle of basically links also, we can assign seed value, segment value. Okay, so at the moment we just start IGP segments, and as an IGP segment first, IGP prefix segments I think next, and then all of these segment types basically we will be discussing now. So, but don't forget this chart. So IGP segments, in the future maybe extra use case might emerge and we might see some extra segment IDs obviously, but as of today, what we have. Okay, so node seed, anycast seed as a prefix seeds we will see, and prefix seed basically to define entire node or group of nodes maybe. Adjacency seeds for the interfaces or maybe group of interfaces. Okay? So more granular way with the adjacency seed. More granular maybe, but it comes as a trade-off, more processing power also, resource consumption. So for me as a designer, it's all about trade-off. And even the inventor of segment routing don't want to use much adjacency seed anyway. But of course, if there is a use case for that, like I want to push traffic definitely over this way. So when you will see in the TI-LFA, for example, we will be utilizing adjacency seed because otherwise we cannot send the traffic over that direction. There will be loop. In order to overcome that, adjacency seed needs to be used. Okay. So each router, node, intermediate system, ISS term, node, and each link adjacency. Link, circuit, adjacency we use interchangeably, okay? Here has an associated segment ID. So either node, and you can use per interface also, or you don't have to use. Adjacency seed is not must, by the way. You need to assign node seed, but you don't have to assign adjacency seed. Adjacency seed, why you do? You want to do somehow forcing the traffic over this way. So traffic engineering, path manipulation, traffic engineering. So prefix seed is associated with an IP prefix. Prefix seed is manually configured from the segment routing global block sRGB range of the labels, and it is distributed by ISAS or OSPF. We are talking IGP, that's why. For example, when it's for the seamless MPLS, when you learn the prefixes via BGP, then BGP segment ID you need. Okay? At the moment, we are talking IGP. Reachability is provided by IGP, that's why seed value is advertised with the OSPF or SAS. There are two types of IGP prefix segments. When we see in the prefix segments in the chart in the beginning, let me show you again. Prefix segments, Anycast or node seed. Now we will be talking about those, okay? Slowly I am going through. Should be very obvious. After maybe 5-10 minutes, things will be much more clear. There are two types of IGP prefix segments, either Anycast segment or node segment. So node seed is a special subtype of prefix seed that identifies specific node, individual node. So what I am saying, either individual node or with Anycast, all the nodes. All the nodes. Anycast, way of deploying IP, way of deploying nodes. Anycast means that. Anycast is not a protocol. Anycast is used for DNS. Anycast is used for CDN, content delivery networking. Anycast, for example, Google DNS works based on that. Same IP address from multiple nodes. Or in multicast, Anycast RP, Anycast rendezvous point you are hearing. Same IP address on multiple nodes. Okay. Here, Anycast seed, same IP or same seed here, not IP address, seed value on different nodes. But use case, of course, is what? Maybe shortest path, or let's say path optimization, or load balancing, obviously. Load balancing, of course. So a node seed we are talking is a special subtype of prefix seed, as we seen in the chart. It is configured under loopback interface with the loopback address of the node as the prefix, and it must be globally unique. So global segment, local segment. Node seed is global unique segment. Later on, when I talk about adjacency segments, they will be local segments, okay? These are global. Global segments, local segment. Guys, things will be obvious. Which segment is global, which segment is local? What does global segment mean? The troubleshooting will be much easier. Local, it will be different. You cannot remember them. You cannot troubleshoot based on it. When you see the label value, you don't know, of course, which interface of which router. You can still have some logic, maybe, but usually it is for the node seed, not the adjacency seed. Okay. An adjacency segment is identified by a dynamic label called adjacency seed, which represent a specific adjacency, such as egress interface to a neighboring router. Maybe between router A and router B, you have 4 interface. Which interface you want to push the traffic? So per interface, you can have different label value. Those specific label value, let's say per interface, It's called adjacency label, adjacency seed. Adjacency seed is distributed by IGP, here with ISS or OSPF, IGP segments we are talking. So adjacency segments steer traffic to the specific adjacency and it is locally unique. As I said, it is for traffic engineering purpose. Traffic engineering purpose, we use it. Do you have to? No. Okay. But let me tell you something. Probably we will see some topologies for this one as well. Let's say you have two paths. One path is utilized by ECMP, so it's the primary path, I mean. Another, normally, without segment routing, if you would just use OSPF or ASAS, wouldn't be used at all. So, as you know, if cumulative cost from the node to the destination, if it's same, then ECMP you can have. If it's not same, then primary will be installed into the reband FIB, and backup will not be used as an active. You can install maybe into the reband FIB as a backup if you enable fast reroute, but not as an active normally. Traffic engineering tools, when you use like RSVP or SR, you can use both of those paths. Both of them as primary, I mean active. SR is one of those protocols that you can push, of course, traffic to even longer path. So shorter path is the cumulative cost, shortest one, IGP cost. Longer path, even if you want, you can use with the SR, not just with RSVP. RSVP, we will later on, of course, compare RSVP with the SR from many aspects, but one of them is obviously bandwidth reservation. You can do it with the RSVP, not with the segment. Okay, so at the moment what I am saying, adjacency label, adjacency seed is used for the traffic engineering purpose a lot. IGP adjacency segment comes with the two types as well. These are layer 2 adjacency seed and group adjacency seed. Let's look at these seeds in more detail. All of them, I mean, node seed, NK seed, adjacency seed, and so on and so forth. Just very high level, I talked about prefix seed. Basically, two types of prefix seed. We have node seed and NK seed. And then after that, we have adjacency seed. It's not prefix seed, adjacency interface. So either you have node-wise, so single node or group of nodes, then we call them prefix seed. And then interface-wise seed you have, so either what we call it layer 2 adjacency seed or group adjacency seed, interface-wise. So node-wise or interface. If node is enough for you, then those either via, if single node, then we call it node seed. If group of nodes you want to send the traffic, then NK seed. If you want to even send the traffic in a interface level granularity, then you need to use adjacency seed, guys. Okay. Cool. First major type of seed is node seed or prefix seed. Node seed represents a node and has a global significance. So that from the sRGB we talked, something like loopback interface of a router. Like an operator assigns loopbacks to their routers, it's expected that the node seed value will be assigned to every node. So loopback interface normally we create. When we create loopback, also we are assigning, if you are running segment routing, we assign node seed value, it is must. So in order to identify that router in the SR domain. Okay, the assigned value can be absolute, we talked about, and or indexed. Why indexed? Maybe sRGB is not the same on each and every router in the SR domain in your network. If same, then absolute value you can assign. All the nodes switch packets towards the node seed via shortest path. So the meaning of the node seed, send me the traffic by utilizing the shortest path. Okay, node seed, send the traffic to that node seed value router by using shortest path. So you mean shortest path, IGP shortest path? Yes, of course, OSPF shortest path, ISAS shortest path. So without adjacency seed then, if you would just use node seed, and if you have multiple paths, you would only use the one of them, the shortest one. But what if there is an ECMP? ECMP is ECMP, you can utilize here. We cannot use ECMP with RSVP, correct? You need to have multiple tunnels with RSVP. Wow, so number of, what's the problem with that? Number of state information. Much more LSPs you will have. So more state, more complexity. More state, more resource consumption. We don't want that. If SR is not possible, what we will do? So if something is mandatory, then we are okay with that. Necessary complexity, we consider it. Necessary. From global significance, we mean here that every node in the SR domain will install MPLS label in the forwarding plane representing node seed. So you have 100 routers. All of those 100 routers will know how to reach to this node seed, guys, by utilizing shortest path, obviously. So whatever IGP tells to that router. Then from that aspect, it is same as LDP, right? Yes, of course, LDP follows. RSVP also follows the by default. By default, LDP as well as RSVP follows IGP shortest path. And RSVP, in addition to that, what it can do, constraint-based routing, which means not only shortest path, you can say, I want maybe longer path. Specifically, you can say, I want not the shortest, but longer one. Or you can say any type of, I want expensive link. And so, yeah, will it be possible with the segment routing? From that aspect, of course, whatever you can do as a traffic engineering with the RSVP, we can also do with the segment routing. Orhan, why then we didn't do it with the LDP? It's a huge discussion. We didn't do. LDP traffic engineering was never implemented on the networking devices. There was an IETF draft though, CRLDP, constraint-based LDP for traffic engineering purpose, but never implemented. So what we are saying, we are deploying MPLS label in each and every segment routing running routers, guys. Okay. How this is different than every router installing a label for /32 loopback interface in the case of MPLS with the LDP, not with the SR, but with the LDP. So we will talk about it. Let's just wait a little bit to see if there is a difference with installing a label with the SR or with the LDP. LDP today, still today in 2021, is the most common MPLS labeling protocol for the transport. Okay. Segment routing is getting attention. Segment routing, we are seeing many more and more deployments, but LDP is LDP. So you are seeing many IPv6 and some V6 only networks, but doesn't mean in 2021 it is more than IPv4 deployments. Okay, so what's happening with this node seed? What's the label operation? How label operation is done? Without, of course, seeing with the topology, it wouldn't be possible to understand. Let's have a look at with the topologies, guys. In this figure, router has been assigned unique node seed values. Here, have a look at, because traffic from source to destination R1 to the R6 will be, but we assign actually node seed value on each and every router, as you can see. So 16,001, 2, then 3, 4, 5, and 6, router 6. So, and then we also assign IGP metric value, IGP cost. So 10, 10, 10, 15, as you can see. Okay, so between R1 and R6, we have many paths actually. This one, right? Or, I mean, this one, so many. I don't know. Lots of them. Okay? Not just because this, in the middle, this square topology also increasing number of paths a lot. But if we look at that, this path is the shortest path, guys. from the IGP cost point of view. Okay, this one 10, 10, 10, 30. This one probably, yeah, the second best, and then maybe this one of this combination is 30, etc., etc. So this one is the top one. What happens here, though? What we do here, 16,006 for the R6 is sent to R2, R2 sends to R3, and so on and so forth. So same value by using ECMP, shortest path, as you can see, is sent over here. R3 is doing PHP, that's why you don't see the label here. But since there it seems sRGB is same, the reservation for the segment routing global block same, they can reserve this value. So R1 assigns 16,006, R2 also assigns 16,006. Actually here, still there is a swap operation, but it's swapping what? 16,006 and to the 16,006. And then when this guy receives, it will remove the top mask label, which is 16,006, and we are sending as data, maybe, of course, in the real networks. If you are deploying segment routing for the VPN, for example, you will see here VPN label, obviously, and then data, payload, right? Of course, I'm not talking about the layer 3 headers, layer 4 headers, etc. There will be after the SR labels, obviously. But then here, what we have, here you can still send the traffic for maybe, let's say this one, shortest, over the shortest path, I want to send MPLS layer 2 and layer 3 VPN traffic. And then over here, I want to send my internet traffic. So what, still you can utilize, I mean, if this would be just IGP network without segment routing, you could only use top path, ECM, shortest path. Why I am saying for every time shortest path ECMP, but I am making correct. So ECMP and shortest path, totally different things. Anyway, here, what I can do for different type of my maybe traffic, I can still utilize. Otherwise, just with the IGP protocols, this path wouldn't be used, guys. Every IGP protocol, OSPF, ISS, EIGRP, all those protocols, they attack the shortest path. But with the TE tactics, so RSVP, segment routing, with those, I can force the traffic to go over the other paths as well. So utilization level of my network will increase, obviously. What can I do here? I am forcing the traffic to go over here by doing what? By basically adding this 16,004 node seed of R4 as well. So because now from this router point of view, in order to reach to R4, there is a two path, either this one or this one. So in order this one to use this link, you can push 16,004 and it comes to here by using this one. When it comes there, so obviously it was for me, so let me remove the top mask label, and what remains 16,006. Now this guy, it will check this 16,006. It means reach to R6 by using the shortest path. This guy shortest path, which one? It could be this way, by the way. It could be this way, or this way, or this one, or this one. All of them possible. Whichever shortest path. So because the meaning of 16,006 node seed is using the shortest path. But obviously this one 20, this one 30, 40, this one again 50 something. So this one is the shortest one. That's why if you push from R1 with this two node seed, two node label, for this one it will use this path because this is the shortest. Node seed always meaning is shortest path. So node seed, shortest one is this one, not this one. So that's why it pushed the traffic over this way in the first place. Then when R4 received, it was for R4. That's why it will remove the top mask label. So remaining label 16,006, node seed. So that's why it needs to do what? Shortest path operation again. And it will check IGP. Which one is my shortest path to the R6? This one. Okay. So far, we are talking node seed operation. Good. We will later on adjacency seed cut. And together, node seed and adjacency seed can be used in a label stack, like LDP label stack, correct? So label stack and so on and so forth. So node seed we just seen as the IGP prefix seed. So what I said, prefix seed when we say either via single node, so it's node seed we call it, or group of nodes, which is any case seed. Group of nodes we will assign now same label value, same seed value. On multiple nodes maybe same label value we will assign. Any case means same thing we will assign. Any case maybe IP address for DNS purpose, maybe any case again IP address for CDN purpose, or seed value for the MPLS purpose, okay. Transport purpose in MPLS network, let's say. Anycast seed, assigning unicast IP address on more than one node in the domain makes that unique prefix and anycast prefix. Anycast IP address mean it's way of assigning IP address, not a protocol, not new technology. Anycast mean way of assigning same thing, IP, label, so on and so forth. An IGP anycast seed is a special type of IGP prefix seed that is associated with that anycast prefix, same prefix value. This seed is not identifying specific node, rather group of nodes. So prefix either via single node, which we call node seed, or group of nodes, which we call anycast seed, guys. Same thing, adjacency seed when I come to the adjacency segments, either via single layer 2 interface or group of layer 2 interface, group adjacency seed we will call it. So prefix seeds then for the entire device. Adjacency, each and every unique maybe interface level or node level. Interface level more granular, of course. So that's why anycast seed is a prefix seed, but not just for single node seed. It is groups. So in node seed and flag is set. So this is for troubleshooting later on we will use when we do the lab as well. With anycast seed and flag is not set with the advertisement. So okay, with the single node and flag. So this is for the node seed. It means we will see. But when we configure anycast seed, sorry, will not. So for the troubleshooting, it will be only important there. Okay, let's have a look at, by the way, what's happening here with the anycast IGP seed. Okay, here we have from this domain two nodes, router 1, router 4, okay, and then we advertise, by the way, of course, each router you can still assign unique node seed. Okay, 16,001, 16,004, maybe. Then 16,014, let's say IP address 14, and then seed, anycast seed 16,014, you are assigning for what? For basically doing ECMP, load balancing. You see here? You see here? That's the idea. So when router 11 receive the traffic, okay, it's, let's say, 16,014. It knows that I need to do hashing and I need to send some flow maybe here, flow-based hashing, and then other flows over here. So I can utilize both of these routers. So, wow, good actually, this way. Anycast advertisement, so I can send the traffic over here or over here. Okay, what if there is, let's say, third node, fourth node, and I don't want to send them? Yeah, good. So you don't assign that same anycast prefix to them then. Or maybe third one as well, but not fourth one, whatever the use case for that. So which ones you will load balance, you assign the same prefix, IP address I mean, on those, and then same anycast seed for them only, and then you just load balance towards those guys. Okay. Cool, but then why router 2 didn't do that? It is sending only to this router. Aha. So we set anycast seed. Why it is not sending over this way as well? So classical anycast, how it works, let me explain. Not just because when we advertise that 16,014, magically everyone they will do from each and every locations towards them the ECMP. No. Based on, again, underlay transport, which is IGP here, underlay transport. So IGP point of view, if these two nodes total cost is same, then they can do ECMP. If not, they cannot. Whenever there is an anycast rendezvous point, for example, it was for the multicast, right? What we were doing, okay, you can do ECMP, but if some sources or multicast receivers just close to the some RP, they just send the traffic to that RP, because it means, anycast mean, okay, multiple nodes maybe, but if one of them only closest to me, others are far away, I will send my traffic to that closest node. But some other nodes closer to the other IP addresses that in that anycast group, they will send to them. So overall, I will have load balancing. I will have all my nodes to handle some traffic. Okay, that's the idea. But if some nodes, let's say, like in this case, router 11, they are equidistant. So here, probably IGP cost 10, 10 or 100, 100. So we can do ECMP. But here, 10, 10, 10. So over here 10, over here 30. That's why R2 only can send the traffic to node 1. So, which means anycast is not magically changing all the rules of routing. It's not. So it is still using IGP cost to reach to that router. And in this case, from the router 2 point of view, it is basically this node 1, the traffic needs to be sent. From the R12 point of view, it might be same. So 10, 10, 20, 10, 10, 20. R12, when, let's say, do the hashing, it can send half of the traffic over here, half of the traffic over here. And then when this guy receives, still it sends, out of that half it receives, it sends all of them towards here, because over here it's longer. And then when R3 receives, it doesn't send traffic to this one. It sends also over the shortest path to this guy. So anycast then also meaning to that anycast seed sent by using the shortest path. Of course, it's prefix seed because. So send using the shortest path. If there is ECMP, then utilize ECMP, of course. If there is not, no. But here, what happens if this guy sent, some traffic will be handled by this one, because from this guy point of view, there is 50-50 maybe ECMP. Then when R3 receive, it will send some traffic over here. When R2 receive, it will send over here, because their primary path here as well as here. So, which means overall, both of these nodes will handle some traffic between these different side space. Okay. Anycast it was less. Still, we used what? Shortest path. It is ECMP aware, as you can see from the node 11 point of view. Provides high availability. Why? If one of these node goes down, let's say R1 goes down, R4 takes entire traffic. Even R2 will send over here, of course, because R2, if R1 goes down, although it was the shortest path, now there is no path towards the R1, so let me send over here, it will do. So high availability as well as load balancing, because some routers will send over here, some routers over here, or maybe this guy point of view also over here as well as over here. So high availability as well as load balancing. Traffic engineering based on high-level intent. Send the traffic to the backbone routers in Paris, maybe, or send the traffic to the spine switches in East DC. This is the use case usually with anycast. What does it mean? Okay, I have multiple data centers. Send by using this DC1 spine switches. And if those guys goes down, so then same, maybe anycast CTU is advertised by the other DC spines as well, and then you can utilize them as well. Okay, clever idea, because towards the end of the DC, the cost between the inter-DC links will be higher, so you will not use them. Okay, so IGP anycast seed, deploying same node value, node seed value on multiple devices as same value. Okay, what about this interface level granular anycast seed? Let's have a look at them. Other most important seed is anycast adjacency seed. They usually represent a single link or group of links, and local significant. Local significant doesn't mean it's not known by other routers. Of course, they need to know. Otherwise, how they will tell you how to do the explicit routing, which means from the source router how you can define end-to-end path, even link by link, interface by interface. So they need to know. But they don't install in their FIP, forwarding table, that value. Who installed the forwarding table adjacency seed value? Only that local router. What about the node seed? Node seed is installed by those ingress routers as well, and those also mid routers as well. Ingress, egress, and mid routers, node seed. Adjacency, only those local routers, whoever will push towards their interface. I will show you now. What I mean by local significance is that remote SR nodes, the other SR nodes, unlike for node seed, they don't install the state information into the forwarding plane for the adjacency seed. So why then we have more resource consumption? Because those individual mid routers, at least they are installing adjacency seed for themselves. Without this, much less state information you will see. And forwarding table is expensive. Yeah. Yeah. So because you are trading off speed with the number of prefixes there. So ASICs, they should do faster operation. They shouldn't keep so much prefix info or label. You have to trade otherwise. You cannot have them all. Only directly connected nodes program the forwarding plane for the adjacency seed, those specific nodes. They are absolute values, not the indexed. You can, because they are locally significant anyway. I mean, even let's say, same label value can be advertised for the adjacency seed by different routers. Because when you send the traffic to that router knows what to do with it. Okay, you need to somehow specify how to send the traffic to that router, and then after that router, multiple interface, then that interface, whichever interface you want to push, needs to be also told to that guy. So absolute values not indexed and allocated dynamically by the router from the dynamic label range, not from the sRGB. sRGB global block, this one local. So in case of iOS XR, they will be allocated from the dynamic label range between this one. So between 16,000 to 24,000 was sRGB. Since adjacency seed has local significance, they don't have to be unique in the SR domain also. So which means different routers can assign, of course, by luck, same adjacency seed value. Now let's see with the topology what happens. Adjacency seed we are discussing at the moment. Okay, so what I am doing here, I am pushing with 16, this is the label stack by the way, I have 3 labels. So green ones are my node seeds and this color is my adjacency seed. So which means send over that interface, whatever this label is showing, whichever interface. 16,000 and 3, okay. From the R1 point of view, obviously this one is the shortest path, so let's say same cost 10, 10, 10, 10, 20, all others are longer. 10, 20, 30, 10, 20, 30, so longer. So this one is the shortest one. I send the traffic over this way, and when actually, normally when this guy sends, it needs to do PHP. So, okay, and this one removes. And when this guy receives 16,003 removes, it comes to me, and then 24,001 is my tell me adjacency seed. Why I put here adjacency seed? Without this one, if I would basically have after 16,003, if I would have 16,006, R3 for the 16,006 would use this path, because node seed means what? Shortest path. And R3 to R6, I have 2 paths, one over here, one over here. Obviously, this one is the shortest path. Normally, without this label, R3 would use this interface, but I want to force the traffic over this path, so which means I have to use the 24,001, which means I have to use the label 24,001 to push the traffic towards this interface. Okay, and then when this guy receives this 16,005, you don't need to push again the agency seed, because from this guy point of view, if you just have 16,006, which is not 6 of R6, it is shortest path here. So the why entire topology I have to show you the requirement for the agency seed. As you can see, when traffic is sent to R3, R3 normally without agency seed would push the traffic towards this interface because shortest path, because node seed means send me over shortest path. But by sending with this value to the R3, what we are saying, R3, from the R3 point of view, this value meaning is to force the traffic over this interface, and he did that. So which means even ingress router needs to know this one is the seed value, label value, which is expected by the R3 for this interface. Without knowing this agency label information in the control plane of the routers, you cannot achieve this level of granular traffic engineering. Okay, agency seed we used for that traffic engineering. Otherwise, if you would without this agency seed, would it work? Of course, would work, but traffic would only follow this path. And when there is a failure, of course, after the failure detection, control plane converge, and whichever second shortest path is, you will use that path. Okay, good so far. Layer 2 agency seed, this is one subtype basically when now we have multiple links in a bundle, and which layer 2 links basically traffic will be sent. Normally, you don't know. It is just hashing job. Maybe over path link 1, maybe link 2, maybe link 3. But maybe you want to deterministically say. So as you can see, yes, determinism. So some applications require this level determinism a lot, like IoT, for example, right? Yes, you want to know, or storage, for example. So they want some customer from you, I want 5 millisecond latency end-to-end, it shouldn't increase, so my storage will not work. So then you may need to have this level of interface, level of granularity. Or maybe mice-elephant flow separation inside the data center when you have layer 2 blah blah blah, though we don't much use layer 2 bundle inside those especially large scale data centers that you need to worry about mice and elephant separation. We don't much in those smaller scales, and in the large scales ones we don't much have layer 2 bundles. So we have layer 3 interfaces, guys. Okay, so link bundles are widely used. It combines multiple layer 2 interfaces in a single layer 3 interface. So maybe you have 8 links in a bundle, but all of them layer 2. So when you have between 2 routers, I'm not going through the multi-chassis bundles, etc. So 2 devices, bundle, layer 2, put them, and when you want to run, let's say, OSPF ISAs, just single OSPF neighborship, that's it, not 8. Right? So reduces the layer 3 complexity in that case. Layer 2 hashing you need to do. And traffic normally is load balance over all its member links, and you don't know exactly which packet will go over which link. So it is based on the hashing function of that local device. If there is a requirement to steer traffic over specific individual path links, though, then layer 2 agency seed is allocated for each bundle member. So more granular, you want to utilize sometimes correct, maybe some type of application, as I told you, maybe storage, maybe IoT, maybe difference in your network. But determinism is here key. So node 1 here allocates, let's say, 30,102 as the layer 3 agency seed, which means sending over. So basically between me and the 2, you can utilize any of them. So layer 3 agency seed. Or for each and every link you can assign layer 2 agency seed. Okay, as the layer 3 seed for the agencies of node 1 towards node 2. So because you have normally also interface between node 1 and node 3. So you can say maybe all of them has the same cost, or maybe total of them is providing something to OSPF and it is shorter than here, but you need to have also layer 3 agency seed here, and some traffic maybe you will force over this path. So layer 3 seed, agency seed, and layer 2 agency, different things. Node 1 allocates layer 2 agency seed for each bundle member. So, which means 30,111, 30,112, 30,113. So 30,112 agency 2, this one, or this one, 112 on this one, I think, this one. So, yeah, for link 1 in the bundle. So then this one is the second one, whatever the link, this agency seed value. But the purpose is determinism. So when let's say if you push the traffic from 11, maybe with the node seed of R1 first, and then 30,102, then which means I don't care whichever link you want to send, do the hashing and send over there. But if you send with the node seed of R1 and then agency seed value 30,112, not 102, 112, you are telling to that guy, I want you to send specifically over link 1. Link 2, another agency seed, layer 2 agency, link 3, another, etc. So that level of granularity we have. Okay, so as I said, 30,102 is used on node 1 to load balance over all those 3 links, but 30,112 is used to steer traffic to over only link 1. So granularity. Okay, so layer 2 agency seed was that one. So IGP agency seed, if we conclude, agency seed provides explicit routing advantage, traffic engineering advantage. So you don't just say, this is your node seed and send the traffic over shortest path. No. You are saying, okay, even if you would use this path, shortest path, I don't want to use shortest path, send over longer path, whatever the reason. Otherwise, it wouldn't be possible to send. Maybe over that shortest path, other ingress routers sending traffic, and they created the congestion. So if you would force also sending over the shortest path, because of that congestion, you would increase the latency, so you don't want that. So you have this available capacity and you want to utilize that one with the agency seed. These are, of course, the real reasons. That's why I said. And for this one, I wrote an article, Orhan Ergun selfish routing. If you type on Google, you will find an article for it. So this explicit routing advantage, which means you can specify exactly where packets should go, not just ECMP decide. Sorry, shortest path decide. Okay. This can be seen as an advantage. Some people may not utilize this at all, so not advantage for them, but some people, very important advantage. For especially segment service provider networks. They have many services, many customers, everyone asks something. So in order to perform all these requests, so this is good tool to have. But at the same time, disadvantage because usually more segments is used. Yes, another thing with the agency seed, maybe you will force couple times between source and destination, couple times these specific interfaces, number of label depth will increase, and it might be a problem for some ASICs on some devices. Okay, it might be a problem for Cisco, it might be a problem for the merchant silicon as well. Okay, not just Cisco. Seed depth shouldn't be a problem. We have some comparison algorithms for the seed depths, by the way. By the way, for the agency seeds, even the inventor of the protocol clearance, basically, what he says, we try to rarely use agency. They don't support ECMP, correct? You don't want to use ECMP here. You want to force the traffic over the specific path you want, and they only express one single link hop. We prefer expressing an explicit path with prefix seeds. We get shorter seed lists with that label depth. So label stack depth is not a problem anyway with them, as problem as agency seed. So with even single transport label end to end with node seed, you can achieve whatever you want, but it will use shortest path. Don't forget. And we spread the demand over all the ECMP paths with the prefix seed. If there is ECMP, you can utilize with single prefix seed, guys. But with agency seed, you cannot. So BGP segments will be next. We will start in the next video.